Now, the following figure shows the distribution of marks of the cards in the two subjects. So, here, the horizontal axis is the marks, and the vertical axis is how many students that have that particular marks. So it shows a curve like that. And we can see on the graph that the marks distribution is rather dispersed. Now, the central one, or the median, or the mode, or actually the average is 65 marks. And then here is a marks for another subject. You can see that the shape of the graph, although not the same, but actually they are similar. They are similar. The average here is 60 marks. Now, Mary's mark for the first subject is here, but Mary's mark for the second subject is there. Now we want to compare which, relatively speaking, which subject Mary performs better. If you look at the graph, I believe you will be convinced that the second subject, Mary, should be better because the position of where she is above the light road. While here, Mary is more or less together with the majority. 呢度咧就有兩個關分，即係 Mary 咧嘅成績嚟嘅。咁咧有兩科嘅科目。咁呢兩科嘅科目入邊咧，我哋會見到第一科咧嗰個統計圖顯示咧，嗰啲分數嘅分配咧係比較順散啲嘅。而咧第二科咧嗰啲分配咧係比較順集中啲。兩科嗰個關咧，雖然望落唔似樣，但係即係如果你詳細啲去認真去諗下嘅話咧，發覺其實咧個形狀係相接近嘅。陣間我哋會討論下呢個形狀。第一科個平均分咧就係65分，咁呢個平均分咧亦都係佢個最多人攞嘅分數，亦都係咧係個 median 三合一嘅 average and median and also the mode are exactly the same marks. So this one is actually a kind of special part. And now for this one, the average mark is 62啦。第二個咧個平均分係62，同樣咧都係啦，嗰個平均數啊、眾數啊同埋呢個中位數咧，全部咧都係62分嘅，三下嘅。咁但係從呢兩個圖入邊，我哋見到啦 ，Mary 嘅分喺呢一度啦 ，Mary 分喺呢度啦，我哋應該可以估計到咧 ，Mary 喺呢個係 mathematics 嚟嘅 ，Mary 喺 mathematics 嗰度咧，嗰個表現咧應該係好過咧 Mary 喺 English 嗰個表現嘅。雖然 mathematics 嘅分數可能會低過 English 嘅分數，但係咧作為佢個即係表現嚟講咧，佢應該係優勝啲嘅，因為我哋見到 Mary 咧喺呢個數學嗰度咧，佢係屬於最高嗰批尖子嘅嗰部分。但係咧喺英文嚟講咧 ，Mary 咧個分數咧就落咗咧個大多數嗰個範圍邊。雖然都係高分，但係都係屬於大多數範圍。咁應該嚟講，我哋就講 Mary 咧個分數咧，即係喺 mathematics 嘅分數咧係會好過，即係個表現咧係會好過英文嘅。Now, in this example, if we calculate the standard score of Mary's marks in English and Mary's standard score in mathematics, we will find that the standard score of Mary in mathematics will be higher than the standard score of Mary in English. 如果我哋用翻星期二所學，即係星期一所學嘅方法，星期二嚟嘅星期二所學嘅方法，計一計咧佢嘅 standard score 嘅話咧，我哋會發覺咧 ，Mary 喺數學科入面嘅 standard score 咧，嗰個數目字咧係會大過 Mary 英文科嘅 standard score 嘅。So what does that imply? without the distraction introduced by now, the average mark is different, and also the degree of spreading is obviously different. 嗱，縱使兩組數據即係兩科目咧，佢哋評分唔同。Now the difference in average marks reveals that the difficulty level of these two subjects are not the same. So that is why comparing them will be difficult. And also, the spreading represents tells us that the diversity of students' performance is great for English. So in this case, we will have a very difficult time when we want to compare the performance in two subjects. But using that tool, that means the standard score, we will be able to simplify the process. Just do a calculation and you obtain a number. And that number already tells you the required information. You can compare easily in standardized way. Standard score 點樣去搞出嚟咧？就係話有啲比較嘛。你真係跟個方法嚟計嗰個數字咧，單憑個數字你已經可以判斷得到咧，佢表現係去到幾好。Okay, now just review what the calculation is. The calculation is like that. Z equals to your number. Z is the standard score. Now X is the number. That means in this case it's memory mark in that particular subject. Subtract the average of that mark and then divide the standard deviation. You will obtain a number. Now that number, will it have any unit or not? For the average, you will have units. Now because the standard deviation also have units, so you divide them so it is a unitless number, just a number. Standard score 咧，要留意咧係冇單位嘅。平均數 bar x 呢個叫平均數 bar x average or the mean bar x have a unit of the original measurement。平均數咧就有原來嗰個數嗰個單位，咁但係分母嗰個 standard deviation 咧一樣都有個單位㗎。所以當你兩個一除嘅話咧，嗰兩個單位就要約咗啦。所以 standard score 咧係永世都冇單位 ，average 咧就有單位嘅，除非你要做統計嗰樣嘢本身冇單位啦。咁以呢個為例，個單位咪幾多分咯？通常幾多分都寫單位嘅，但係個單位係分嘅。Okay, understand that? So that is the use of standard score.
Which one?
You will encounter calculations. Just remember how to operate your calculator and do the calculation. I just want to talk about the shape of this one. Now, for this, experiments tell us that many researchers do many experiments. If there is no special influence on a set of data. For example, in the examination, some group of students is cheating. Now, assume without this kind of thing. So, if the number of students participating in a particular examination is large enough, their score will tend to look like a graph like that. And this distribution is called the standard distribution. Standard distribution. 有好多研究學者咧做咗好多研究，咁佢哋得出嘅結論咧就係話，如果有某一啲嘅數據，佢哋咧係唔受一啲特殊因素干擾嘅話咧，只要統計嘅對象夠多，咁得出嚟嘅數據咧呈現嗰個分佈狀態咧係會自然地係會係一個咁嘅現狀。而呢一個咧就叫做標準嘅分佈 （standard distribution）。Of course, this is just a theory. If you really do some statistics, probably you won't get exactly this standard distribution. But it is very likely that the information you obtain will resemble this closely. It looks like this closely. So this is just a method, a simplified method, just to help us to analyze the data. But I'm not going to go into details about this one. Just notice that this shape is known as the standard distribution, and that will be the normal, your expected result if there's no bias in the experiment. There's no bias in the data. 如果個數據係冇呢個特殊因素影響嘅話咧，得出嚟嘅只要你嘅統計夠多嘅話咧，就會有一個情況。Now, just want to give you one more example. Suppose you are buying things in the supermarket, the prepackaged food. The labeling said that the content should be 1 kilogram. But all of you know, if you buy a box and then open it and make the weight measurement, it will seldom be exactly 1 kilogram. Sometimes it will be a little bit more, and sometimes it is a little bit less. And if you buy enough of the same stuff, you should expect the weight distribution will look like this one. Now, the characteristic of this one is the V1, I have already told you. Now the mean is at the middle. Mean is at the middle. And also, it is the most likely result. So it is also the mode. And because it is in the middle, it is also the median. So average, median, and mode are exactly the same number. So this is the characteristic of this one. And this is also what you expect. If you buy the packaged food from the supermarket, you expect that most likely it will within a narrow range of that 1 kilogram. Or maybe it will be more likely like that if the quality control is good. But nevertheless, you expect that some will be overweight, some will be underweight. 即係如果個質量控制好嘅話咧，我哋會預期咧就得出嚟個結果會咁樣。絕大多數咧喺嗰個飆升嗰個重量嘅範圍附近，但係亦都會有啲加減嘅。Unless the company that's selling you the food are cheating. Okay, now this is called the normal distribution. And there is a whole lot of statistics, a whole lot of a subject that just study this one. A very involved topic, and you can make use of it to do many maybe wonderful things. Many researchers make use of the property of this graph to make prediction before they even conduct the experiment, and then they end up come up with some conclusion. Okay. 呢個咧叫做standard distribution 咧係一個好有用嘅工具啊。So if you study N1, one of the major topics you will study is the property of this standard distribution. 如果你讀 N1 嘅話咧，其中一個好重要嘅課題咧就係研究呢一個 standard distribution 咧呢個 curve 嘅特性，點樣用佢，點樣用佢嚟炸一啲嘅數據出嚟，點樣用佢嚟咧係做一啲嘅判斷，認為嗰啲數據可唔可靠啊，或者比較兩組數據，到底A 嗰組數據係大過 B 嗰組數據嘅機會，到底大唔大咧咁樣？所以話呢啲係呢啲科學嘅。So when you are comparing these two, you see that if you just take a sample from test 1 and a sample from test 2, you may not be correctly conclude that test 2 is better than test 1. 嗱，呢度舉例子嚟講啦，譬如咧呢度有個生驗1、生驗2，好明顯咧生驗2嘅分數高過生驗1㗎。但係如果你是但抽一個人，你要睇佢生驗嘅分數，有可能佢喺生驗1同2嘅分數高過喺生驗2 分數係嘛？因為差異一同差異二嘅分數咧有個重疊㗎嘛，佢唔係完全高過晒啊嘛，所以你咁有機會抽到咧，差異二係低分啲，譬如呢個部分，差異一咧就喺呢個部分抽到，即係你抽個樣本出嚟做比較嘅話咧，就變咗唔可靠啦。咁但係有幾唔可靠咧？咁就可以用統計嘅方法咧嚟計到個數字，話到俾你聽咧，呢件事到底靠唔靠得住，可唔可靠？你信唔信得過佢？Okay? Okay, let's look at an example. Now this example. Example 4.12. Henry and Jane players of the boys and girls softball teams respectively. Henry is 176 centimeters tall and Jane is 169 centimeters tall. Now Henry's office is smaller than Jane. The male member has a height of means 170 and a standard deviation of 4.5. The female member has height with a mean of 164 and a standard deviation of 3.6. Now, which player is relatively taller among their teammates in their home team? Now, how to compare? Easy. Just calculate the standard score of each of them respectively. The standard score of Henry is 1.33, while the standard score of Jane is 1.39. Obtaining the numbers, you know that Jane is relatively taller than Henry. 其實咧，去到呢啲咧，就真係用公式就咁計嘅啫。So that's why you need to memorize the formula for calculating standard score. 你需要背嗰啲公式嘅計 standard score。攞啲數據嚟計出嚟嘅數字，邊個大啲，邊個就高啲咯。Well, I just want to discuss one more example with you. There is a trap. There is a trap. Okay, now please try to do this one. Further practice. Try to do further practice. Okay? And be aware of the trap. Mary completed the 100-meter event in the academic in 14.2 seconds. The standard deviation of the time of all the contestants in this event is 0.92 seconds. The standard score of Mary's time is 0.33. A. Does Mary perform better than the average? The standard score of Mary, not Mary, but May. The standard score of May's time is 0.33. Does May perform better than the average? Now, 0.33 is greater than 1. That means May is above average.
No.
嗱呢條咧就話咧阿 May 咧嗰個 standard score 係0.33，咁佢問你阿 May 咧係咪比平均嚟講係好啊？嗱0.33咧，即是話咧佢係高過平均數啦，因為正數嚟嘅。However, in this example, because we are talking about the time to complete the race, the longer the time is poor the performance. 呢條咧係有即係陰秋嚟講嘅。諗啊，用腦筋見到哇0.33大過1個，即係大過0個，咁梗係好啦。咁唔係嘅，因為呢個係講緊個時間喎。完成比賽嘅時間梗係越快越好啦。So C1VB is actually below average. She took a longer time than the average to complete the race. So no, the answer for this one is no. Okay, now found the mean time of all the contestants. How to do it? Well, actually, when you look at 14.2, you know that it is slow. She is slow. But點計個 mean time 咧 ？How to calculate the mean time? Now, making use of the formula. The formula is the standard constant equals to x minus pi x divided by the standard deviation. Now, z is 0.33, a known value. X is the time of May, the time of May is 14.2 seconds. The standard deviation is 0.92. So the only unknown is the average bias. So by making use of this formula, you will be able to find the mean time. It's okay? Now be careful of the calculation. And if you are not sure, if you do not have confidence in your after doing the calculation, put it back to see whether the right hand side can produce 0.33. 嗱，如果你覺得自己計算起上嚟論盡咗咧，計完咗嗰個平均數咧，擺翻落原本公式嗰度再撳多次機，睇下計唔計得到0.33。如果你右手邊撳計到0.33，即是原來你運算冇錯啦。我覺得你係值得花時間去即係咁樣 double check 嘅。如果唔係嘅話咧，其實你有機會識嗰啲你就攞5分，咁唔識嗰啲梗係冇得講啦。So try to use your calculator to see whether you obtain the answer. And here the answer should be 13.9. This might have not been used for a long time, so the content is good. Now, for the last part, you just use the formula to do it.